Okay, so let's think about some ways in which we can use the different models from this chapter to answer some probability questions. So the first thing we're going to want to do is to identify which model is the model that we want of the discrete models. And there's a couple ways you can tell. So first, one thing you can do is you can ask, is this asking a yes or no question multiple times? Is the fridge dented? Did the stock market go up? Is it raining today? I mean, those are all yes or no questions, and you can ask them multiple times. So what's the chance it rains 5 days out of 7 if it rains half the time on average? Well, that's a yes or no question. Is it raining? Asked lots of times. So we want to make sure that we're asking yes or no questions because those are the kind of questions that can be answered with um, discrete probability distributions. Even the Poisson, you're asking how many events occurred in that time or space, which isn't strictly a yes or no question, but you could think about it as, do we have one? Yes. Do we have another one after that? Yes. And then you keep asking that over and over until the answer is no. Which brings up the second point. Is there a limit to the number of yes answers? Hypergeometric and binomial have a limit to the number of yeses. But Poisson has no limit to the number of yeses. Okay. Now, another hint that we can use is to track the numbers we are expecting. Okay, so if I have a binomial, I have 3 numbers. I have 2, I have the number of yeses, and the number of tries to get a yes. Those are both whole numbers. And then I have the probability of yes, which is a decimal, less than 1. That's binomial. If I have a Poisson, there is no limit to the number of yeses, and we can ask how many do we want, and then also the number we, put this in a different line, the number we expect. This may be a decimal. So for example, you can think about saying, well, I expect 12.2 cars to show up during the lunch hour at McDonald's, but it doesn't make sense to say what's the chance 12.2 cars show up. We can have 12.2 coming on average, but in reality it's going to be either 12 or 13 or some other number. So the number we're expecting has to be a whole number. The number we're asking about has to be a whole number, but on average we can have a fraction. So the last one, hypergeometric has 4 numbers. We have the number of yeses, number of tries, and then the number of yeses available, and the number of observations, or let's see, total number of everything. And so if you've got, I'm going to pull 5 balls out of a bingo cage and hope for 3 in the top 20, and there's 40 balls in the cage, so the total will be 40. The number of yeses is 20, right? 21 through 40. I'm going to try 5 times. I'm going to hope for 3. So in Excel, I would write equals hypergeometric 3, 5, 20, 40. The last is choose, and that uses two numbers, and you're not finding a probability, you're finding a combination, so it's going to be the only model that gives you results bigger than 1. And so you get the number of things to arrange, and then the number in the arrangement. So if I've got 27 players on a baseball team, if I allow everybody to play whatever position they want, you'd have 27 players to arrange and 9 players to choose out of that list. Okay, so those are some of the shortcuts that'll help us figure out what we want to do, or what we want to do in terms of model choice to answer questions. So let's go take a look at some of these. So here we've got a question. We've got 24 baseball players. Choose 9 for a lineup. How many different ways? So that is a choose question. 2 numbers, none of them decimals, and it's asking about arrangements rather than a chance of an event. What's the chance the stock market goes up 10 years in a row, assuming it goes up in 60% of years? Well, is this a yes or no question? A series of them, yes. So the yes or no question is, did the stock market go up this year? And we're going to ask that question 10 times. So, are we asking a yes or no question multiple times? We are. Is there a limit to the number of yes answers? There is. 10 is the limit. We can go up at most 10 times in 10 years according to this question. So because there is a limit, we can eliminate Poisson as an option. So it is not the Poisson model. It is either binomial or hypergeometric. So if it's hypergeometric, we'd have 4 numbers, no decimals. Binomial, we'd have 2 numbers, 1 decimal. So we have the chance the stock market goes up 10 years in a row, assuming it goes up in 60% of years. We have 10, the years we're trying, 10, the number of yeses we want, and 60% the probability. So this is a binomial model. What's the chance the market has 3 or more 10% or higher returns in 1 year? That's from 0.8 on average. This is an event in time and space. How many 10% or higher returns in 1 year can we have? Well, there's no limit to that. You could have 20, 80, even though it's not likely you'll have more than 1 or 2 according to this model. And so that means since there's no limit, this must be a Poisson. And that fits because we have 2 numbers. We have 3 or more, which tells us what we're looking for in terms of number of events, and we have a decimal 0.8. Okay, and lastly, we pick 5 stocks out of a list of 20. What's the chance you pick 3 stocks that are in the top 10? This is a series of yes or no questions. Is the stock you chose in the top 10? So we are choosing 3. We're choosing 5, hoping 3 work. We've got 20 available with 10 possible yeses. This is a hypergeometric question.